A solid cylinder of mass m and radius r rolls without slipping down an inclined plane of length L and height h. What is the speed of its center of mass when the cylinder reaches its bottom? Answer is root 4 by 3 into gh. A ball rolls without slipping. The radius of mm, gyration of the ball about an axis passing through its center of mass is k. If radius of the ball b r, then the friction fraction of total energy associated with its rotational energy will be k square by k square plus r square. Consider a system of two particles having mass m1 and m2. If the particle of mass m1 is pushed towards the center of mass of the particles through a distance d, what distance would the particle of mass m2 move so as to keep the mass center of particles at the original position? Answer m1 by m2 into d. Two bodies have their moments of inertia I and 2I respectively about their axis of rotation. If their kinetic energies of rotation are equal, their angular momenta will be in the ratio 1 is to root 2. The moment of inertia of a uniform circular disk of radius r and mass m about an axis touching the disk at its diameter and normal to the disk. Answer is 3 by 2 into mr square. The ratio of the radii of gyration of a circular disk to that of a circular ring, each of same mass and radius around their respective axis, is 1 is to root 2. Four identical thin rods, each of mass m and length L, form a square frame. A moment of inertia of this frame about an axis through the center of the square and perpendicular to its plane is 4 by 3 into ml square. The moment of inertia of a thin uniform rod of mass m and length L about an axis passing through its midpoint and perpendicular to its length is I0. Its moment of inertia about an axis passing through one of its ends and perpendicular to its length is I0 plus ml square by 4. When a mass is rotating in a plane about a fixed point, its angular momentum is directed along a line perpendicular to the plane of rotation. The ratio of the accelerations for a solid sphere, mass m and radius r, rolling down in an incline of angle theta without slipping and slipping down the incline without rolling is 5 is to 7. The ratio of radii of gyration of a circular ring and a circular disk of the same mass and radius about the axis passing through their centers and perpendicular to their planes are root 2 is to 1. A disk and a sphere of same radius but different masses roll off on two inclined planes of the small altitude and length. Which of the two objects gets to the bottom of the plane first? Sphere. Central of mass of a body is the point at which the total gravitational torque on the body is zero. Mechanical advantage greater than one means that a small effort can be used to lift a large load. If the mass of the sun were 10 times smaller and the universal gravitational constant were 10 times larger in magnitude, which of the following is not correct? G on the earth will not change is wrong answer. If universal gravitational constant becomes 10 times, then G is equal to 10G. So acceleration due to gravity increases. That is, a solid sphere is rotating freely about its symmetry axis in free space. The radius of the sphere is increased, keeping its mass same. Which of the following physical quantities would remain constant for the sphere? Angular momentum. Three objects A a solid sphere, B a thin circular disk, and C a circular ring. Each have the same mass m and radius. They all spin with the same angular speed w about their own symmetry axis. The amount of work w requires to bring them to rest would satisfy the relation. Answer WC is greater than WB is greater than WA. Two particles A and B are moving in a uniform circular motion in concentric circles of radii RA and RB with a speed VA and VB respectively. The time period of rotation is the same. The ratio of angular speed of A to that of B will be 1:1.